Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be looking at trig integrals, specifically when both degrees are even for a sine or cosine function. An example would look like this. If I have the integral of just sine squared x dx. This problem is not as easy as you think it is, but here is what we're going to do whenever the degrees are even. The first thing I'm going to do is I'm going to convert all of my even degrees into the double angle formula. What do I mean by that? So just to give a quick background here, you normally don't have to write this part in your work, but cosine of 2x, that function, has three different forms. The first form is cosine squared x minus sine squared x. The second form is 2 cosine squared x minus 1. And the third form is 1 minus 2 sine squared x. The reason why I'm showing you this is because you can solve these functions for different variables. Like for instance, if I solve the 2 cosine squared x minus 1 and I solve for cosine squared x, then I get cosine squared x equals 1/2 times the quantity 1 plus cosine 2x. And this is one of the identities that I highly recommend you memorize for these integrals. The other one is when you solve for sine squared x, and that gets us sine squared x equals 1/2 times the quantity 1 minus cosine 2x. And again, have these two memorized in the blue boxes. I don't even care about the red text. It really doesn't matter. You don't need it to solve these trig integrals. But for this first one here, when I have integral of sine squared x, I'm just going to replace it with what I wrote just a second ago. 1/2 times 1 minus cosine 2x. And it now will look like this. The integral of 1/2 times the quantity 1 minus cosine 2x, close parenthesis, dx. The reason why this is so nice is because this is a very easy integral. The 1/2 just goes out in front. Integral of 1 minus cosine 2x dx, and then we just know this integral because the integral of 1 is x. I won't forget the 1/2 out in front. And then the integral of negative cosine 2x, it's going to be minus, and then the integral of cosine is positive sine, so positive sine of 2x, and then you have to do a u substitution there. I'm going to skip the steps of the u substitution because I can do it in my head. If you cannot, you'll do the u substitution by hand, and the result will be a 1/2 out in front of that sign. So then this is our integral, and of course, plus c. And you can write this as your final answer, although some teachers and professors will force you to undo your double angle formula. What do I mean by that? I'm saying that this sine 2x, we need to get it back into just x. And to do that, we need to remember this double angle formula. Sine 2x equals 2 sine x cosine x, another formula you should have memorized. And that's going to be x minus 1/2 times 2 sine x cosine x, close parenthesis, plus c. If I simplify this, the 1/2 and the 2 here will cancel, and I will get 1/2 quantity x minus sine x cosine x. You can distribute the 1/2 if you want, I don't care, and then plus c. And there's the answer for the even degree. So for the even degree, the trick is remembering that double angle formula, identity, and then that's basically it. So we're going to look at one more example. For this one, you'll notice it will be harder. It will require more steps, and that's because this time I have sine squared x and cosine squared x. And you're going to notice I'm going to do that double angle formula step. I'm going to do it twice for this problem. So then the very first thing I do when I see this problem, I rewrite sine squared x, that's the 1/2 quantity, 1 minus cosine 2x, close parenthesis, and cosine squared x is the same thing, but 1/2 1 plus cosine 2x, close parenthesis. So when I rewrite this integral, and I can pull the two 1/2s out in front to make 1/4, that's fine. It's going to be 1 minus cosine 2x times 1 plus cosine 2x dx. Now this is not fun. I do have to distribute this and FOIL it out. I'm going to get 1/4 integral of 1 minus cosine squared 2x dx. And if you don't believe me, you can see for yourself that the middle terms cancel, and you're just left with this. Now this looks like a Pythagorean identity. That's because it is a Pythagorean identity. This is equal to sine squared of 2x. Normally it's just sine squared x, but since this is 2x, that's got to be 2x. And now my integral is really this, 1/4 integral of sine squared 2x dx. You'll notice, again, we have an even degree here, which means now I'm going to have to use that double angle formula again. Before I do that, one thing I just want to point out at the very beginning of this problem. The reason why I'm treating this like the even degree case is because all the degrees are even. Sine and cosine are even. If either one of those was odd degree, like cosine cubed, for instance, I would not be doing this. I would be following the rules for odd degree case, which I cover in another video, so you can check that out. But I just wanted to mention that because it's important to know that. So anyways, sine squared, it's the same double angle formula as before. 1/2 times the quantity, 1 minus cosine 2x. And something's wrong here. What's wrong? Before it was cosine 2x because the angle was just x here. Now that the angle's 2x, this is actually going to be a 4x. And the rule is whatever angle you have here, like in this case it's 2x, it's always going to double. So for instance, if this was 6x, then that would actually be 12x. Hopefully that makes sense. So now, here is my integral, dx, still the 1/4 out in front. The 1/4 and 1/2 combined to make 1/8. And then we know this integral, it's just a simple u substitution on the cosine. It's going to be 1/8 times the quantity. Integral of 1 is just x, minus integral of cosine is positive sine, so sine of 4x. And don't forget, because of that u substitution, there is going to be a 1/4 out in front right there. Close parenthesis plus c, and there's our answer for that one. Again, you can distribute the 1/8 if you want. I don't care personally. And this is it. So hopefully these even degree cases are starting to make more sense. If not, please post in the comments below. I'd be happy to take your questions. Have a great rest of your day, and I'll see you in the next video. Bye-bye.